Hello everyone, this is LeetCode 13, Roman to integer. So we're given Roman numerals that are represented by 7 different symbols, right? This is the symbols, right? And these are the values for the corresponding symbols. So for example, 2 is written as II in Roman numeral. We just add the two ones together. 12 is written as XII, which is simply X plus II, right? Basically, we're just given in us an input string that's a Roman numeral, and we have to convert it to its integer representation. Now, it's really simple to, like, when we have something like VI, that's just 5 and 1, right? So we just do 5 plus 1. Really, the tricky part is understanding what you should do when you have something like this, like IX, right, which is 9. How do you convert this to an integer? And really, the trick that you just need to know is that when you have a Roman numeral that's, first of all, that's smaller than the next one, what you're essentially doing is you're taking the first Roman numeral and you're subtracting that, right? And then you're adding the next Roman numeral. So for example, I is 1, x is 10. So you're subtracting -1 and then taking that and adding 10 to it. So this obviously would give you 9, right? Which is what we expect, right? When we have ix, right? That's basically doing -1 plus 10. And it gives you 9. The reason I say -1 plus 10 rather than 10 minus 1 is just because this is easier to understand in the context of how we're going to code up our solution, okay? So let's get to it. So honestly, I'm just going to copy and paste our hash map because we are going to use a hash map to make this problem easier to solve. I'm just going to paste this just because I don't want to sit here and write it down for like a full minute. But right, we're just making a hash map, right, of the Roman numerals, where the key is the symbol and the value is the actual corresponding integer, right? I is equal to 1, b is equal to the integer 5, x is equal to 10, etc. Okay, so we're just making a hash map. The symbols are the keys. The actual integer representation of such symbols are the values in the hash map. Okay, and we're going to call it this hash map Roman map. Okay, now so we're given we're given Roman numerals as input, and it's a string. Okay, so let's iterate through this string. Okay, so we're gonna say int I to 0, I is less than n, I plus plus. Okay, we're gonna have to have a for loop. Now we need to define n, obviously. So we're gonna say int n is equal to, and our input is called s, so we're gonna say s dot size, and we need to have the integer. The integer representation we need to return as an output, right? So that's gonna just be total. That's what we're gonna call it. Then on here we're gonna return total. Okay. Now we need to do two things, right? Remember how I said when we have something like I, we need to make sure that the next value that comes next, we need to make sure we need to check if it's a smaller number or a bigger number in terms of the actual Roman numeral, because if it's a bigger number, we need to basically subtract this and then add this. But what if we're at this I and we're checking, what if we have an x here, right? We need to subtract this I if we have a bigger Roman numeral. Well, what if this is the last input? That'd be problematic because we'd be checking out of bounds, right? Meaning this is the last index in the string. We'd be checking out of bounds if we try and check the next character. So first of all, let's check the index and make sure it's in bounds. We're going to say if I plus 1 is less than n. Okay, so we're just making sure we're in bounds when we check the index to the right of wherever we're at. Okay, and then on top of that, we're going to say Roman map s of I plus 1. And this is why we use the hash map, right? Roman s of I. So what this is doing, okay, is imagine we are at something like an I, okay? Now, when we check the next index, right, we're basically getting, like, for example, we might have an x here, right? We don't know if it's an x or not. So what we're doing is we're getting this next symbol, plugging that into the hash map. So we'd plug x into the hash map. And so this would return 10. Is 10 greater than the current symbol we're on, which would, when we plug this I into here, we get a 1. So basically it's checking, is 10 greater than 1? It is. So what do we do when the next symbol is greater than the current one we're on, right? Right, we have an I. The next symbol is greater, right? Because this is a 1, this is a 10. Well, when we do that, we have to just subtract the current symbol that we're on, which would be I. So we're going to just say total minus equals Roman map S of I. So we're subtracting -1 in this particular example. Okay. Now, let's say we have something like xi, right, which would be 11. In that case, we just add this 10, right? Because we add this 10, and then when we move to the next index, as we keep iterating through a for loop, we're just going to add this. We're just going to add this, right? We're going to add 10, and then we're going to add 1. So that's where the else statement would be. Whoops. Where the else statement would be. So this is where we do total plus equals Roman map S of I. Okay. Then we return the total. Let me remove this comment. We're going to add this. So yeah, it's a pretty clever solution. I'll run through some examples just so you understand what we're doing. Okay. So we have I, right? Well, so when we're at this first I, the next symbol is not greater than the current symbol. They're equal, right? So we go to the else and we just add 1. Go to the next one, we add 1, right? Now, when we're at this last one, right, I plus 1 is out of bounds. So we would just add this last one. We would just go into the else statement also. And basically we add 1 plus 1 plus 1, and we get 3. Now, let's say this example 2, which is LVIII. Okay, we're at this L, which is 50. Now let's check this V. Where is V? Is the next index, right, which is V, is that greater than the current one, which is no, because 5 is not greater than 50. So we would go into the else and we would add 50. Okay, let's go into this V. Okay, is the next symbol, which is an I, is that greater than the current one, which is 5? No. So we add 50 plus 5, right? So we have 55. And then this here is obviously this thing, the same process we used up here. So it'd be 50 plus 5 plus 6, 7, 8, right? So we had 58. Okay, I'm just going to draw the third one out in a comment just so I can keep track of as we go along. So the first symbol is M. So it'd be 1,000. Is C greater than M? No, because 100 is not greater than 1,000. So and let me just keep track of the total as we go along, right? So we add 1,000 and move on to the C. Okay. Now, when we're at the C, let's check the next one. Is 1,000, which is the next one, greater than the current one, which is 100? Yes, it is, right? We're currently at C. The next symbol to the right is actually 1,000. That's greater. So we're going to subtract 100. Okay. So we had a total is 1,000. We're going to subtract 100. So we'd have 900. Let's move on to the next symbol, which is this M. Okay, we're at this M, which is 1,000. Is the next symbol, which is X. X is 10 greater than 1,000? No, it's not. So we go into the else statement. We just add 1,000. So we have 1,900. Now we move on to this X. Okay. Now when we're at this X, let's check the next symbol to the right of that. Is C greater than X? Yes, 100 is greater than 10. So we're going to subtract X, okay, because we're in the if statement. So we're going to have 1,890 in that case. Okay. I have 1,890. So we're going to move on to this C. Okay. And the next symbol to the right is I. Is 1 greater than 100? Of course not. So we go into the else statement, we add 100, and we have 1,990 in that case. Okay. move on to this I, right? Now, is V greater than this current one of I? Yes, right. 5 is greater than 1. So we subtract 1 because we go in the if statement. So we'd have 1989, right? And then we're at the last one, of course. We're out of bounds when we check in the index to the right. So we just add the current, we go into the else statement in that case. So we just add V, which is 5. So we have 1994. Okay. And of course, that is our expected output. So that's how our algorithm works. It's relatively simple when you understand what we're doing. It's a little bit tricky to come up with on your own though, but it's pretty elegant for sure. But I don't remember if I submitted. I think I did. But yeah, anyways, I hope this helped, and I'll see you in the next one.